Okay, welcome back. In this video, I'm going to be talking to you about radians as a way to measure an angle. And, you're very familiar with degrees, and that's great. But eventually we're going to be moving on from degrees to radians, which is really, in pretty much every way, a superior measure of an angle. And what I want to remind you of is that, we definitely know that an angle can be something that represents where, two lines are meeting up, part of a triangle, part of a polygon. But it can also be part of a thing that's like blocking off part of a circle, like you see in the diagram. And a circle is where we're headed with this stuff. So I think, we could say that this angle, this represents, approximately 90 degrees. It looks like it's pretty close to a right angle. But for the sake of our discussion today, I want to talk about a circle with radius 1. Okay, so here I've got a circle, and we're just going to suppose that the radius equals 1. And then I'm going to cut it right where you see that little red mark. And then I'm going to kind of open out the circle into a straight line. I'm assuming you've heard that the circumference of a circle is 2 pi multiplied by the radius of the circle. So the length of this line segment right here, that's going to be 2 pi. And I think that's kind of believable. I think that's right. But I might be interested in scaling this line segment down so that it had a length of 1. And the idea here is if I took this line segment with length 1 and I went over and took it and applied it onto the circle, like was able to bend it appropriately, I guess it wouldn't be a line segment anymore, but with the lower edge of the line segment hitting the place where I cut, that red line, that would represent 1 radian's worth of angle. Okay, so I'm gonna put it in here, and this is really an approximate sketch, but I think it would be about there. And so that is going to measure 1 radian. But believe it or not, 1 radian is actually a very uncommon angle measure to talk about, in trigonometry or geometry or anything. It's going to be other types of numbers. So I'm going to just, instead of scaling that original 2 pi line down to 1, I might think about scaling it down just to 1 pi. And so if I took that thing and I cut it in half and it was 2 pi, well now it would have a length of 1 pi. Okay, but also, if this is half of the circumference, I know that if I went and lay it down on the circle in the exact same way, it's going to go exactly halfway across the circle. And that's going to be something more useful for us as like a conversion factor. Okay, we're going to say that this now represents pi radians. So pi radians is half the circle, and you know that in degrees the circle is 360. So that's going to be our definition of the conversion factor for radians to degrees. The 180 degrees is equal to pi radians. Okay, so let's do a couple of examples. I think obviously always the most obvious question that people ask is like, okay, well, what is 1 radian in terms of degrees, or what's 1 degree in terms of radians? And we can do that. Okay, we're just going to use that conversion factor that we just wrote down. Okay, so I've got 1 radian. And I know a lot of my students are also in chemistry and algebra too, so I'm going to do this like I was taught in my chemistry class when we're kind of converting between units. Okay, we're going to multiply by the conversion factor because really, like, if 180 degrees is equal to pi radians, then if I divide them by each other, I take two things that are the same and divide them by each other, it's like 1. So I'm multiplying by 1 here, and I'm just like letting the units cancel off. So if I'm going to cancel units, I need radians down here. So it's going to be pi radians down here is equal to 180 degrees up here. And then I can cancel off the radians, and it's going to be pi divided by 180. Okay, if you consult with a calculator, you get that that's equal to 57.296 degrees. See, like, not exactly a number of degrees that we work with all that frequently. Okay, but pi radians, you'll see in the future, we work with 180 degrees quite a bit. And actually, you've seen it in geometry class when you talk about supplementary angles. Okay. And I guess while I'm going over here to convert 1 degree to radians, I'll mention like what the utility of degrees was. Like, what's the advantage of using a degree in the first place? And the reason why they chose 360 for a circle is, it's the same reason that we have 60 minutes in an hour and 60 seconds in a minute. It's because 60 is like a really, really nicely divisible number, and 360 is even more divisible. So I'm going to do the same thing. I need to cancel off degrees, so I'm going to put that down here. 180 degrees is equal to pi radians. And I think it was the Babylonians that used the base 60 number system, and like there were still vestiges of that hanging around, like hours and minutes or degrees in a circle. Okay, so pi divided by 180, you could type that into a calculator and you would get that's equal to 0.017 radians. Okay, and that's just us converting radians to degrees, degrees to radians. Okay, now you try it on your own. This is really the only skill that I'm trying to build today, besides just like kind of the idea of what does a radian mean. Convert 0.123 radians to degrees and convert 123 degrees to radians. So just do this exactly like I did it before, and you can check your work against mine. You should pause the video because I'm just going to bring in the answers here in a couple seconds. All right, there you go. So I went in, kind of set up my dimensional analysis type situation, canceled off the units, multiplied the numbers, and I got 7.047 degrees is equal to 0.123 radians, and 123 degrees is like a little bit more than 2 radians. And that's really all there is to it. I don't need you to know a whole lot more besides what I'm about to tell you. All right, so really these are like the radian measures that we really need to know. And I think, eventually you kind of just like default to knowing pi over 4, pi over 3, better than 45 and 60 degrees. Okay, but what I want to show you is like, okay, we're always going to, when we have this trigonometry mindset, kind of start off thinking about, like an angle from the positive x-axis. Okay, so no angle, well, that would be like theta equals 0. Okay, but then, if we opened up 30 degrees, like, something about like that, if that's 30 degrees, I'm just going to say it is, if that made a 30-degree angle there, then we would just kind of label that point on the circle and say, okay, well, that was 30 degrees up the circle. That's going to be pi over 6. Okay. And then we can look at pi over 4. That's 45 degrees up the circle. And that'd be about there, halfway between 0 and 90. So that's pi over 4 radians, and I just did that for you because really what I did was I think you can see that we can go backwards and forwards from 180 equals pi radians, right? 90 degrees is going to be half of pi. 60 is a third of 180, so I could divide pi by 3 to get from 180 to 60. Okay, the fact that 45 is pi over 4, well, I guess that's half of pi, half of 90 degrees. And, pi over 6, you can work it out from there. Yeah, I trust you. So I might also say, okay, 60 degrees, pi over 3. It would be about here on the circle. This is very approximate. Okay, right there. And then pi over 2, well, that's 90 degrees. So a 90-degree angle from the positive x-axis, well, that would be the positive y-axis. Okay. 180 degrees is a straight angle, so it would be like, if I started out from there and then I went all the way back there, that would just be a straight line. That would be 180 degrees worth of angle. So I'm going to say pi radians is going to be over here, and we'll talk about this quite a bit more in the next video. And 360 degrees, that's 2 pi. That gets us all the way back to where we started, which was at red. Okay. I think that's going to be all for this video. I don't think I really want to tell you a whole lot more about radians until we're ready to actually do some unit circle stuff and look at trig functions on that unit circle. So that's going to be all for this video. As always, thanks for watching.